Now, what I have here is trying to find the derivative of y equals sine of x. So I set it up as the sine of x plus h minus the sine of x over h. And again, I cannot handle the sine of x plus h by distributing sine in. I have to use my summation formula for sine and recognize that if I have the sine of a plus b, it's the sine of a times the cosine of b plus the sine of b times the cosine of a. So in the case of the sine of x plus h, I've got the sine of x times the cosine of h plus the sine of h times the cosine of x, and then I'm still subtracting from it the sine of x, so it's all over h. Now, I'm going to do something I'm not asking that you would know to do this, but I have worked this problem before, so I know to do this. I'm going to have that y prime is going to equal to the limit as h approaches 0 of, and I'm just going to reverse the order right here. So this is now going to be the sine of x times the cosine of h minus the sine of x plus the sine of h times the cosine of x all over h. All right, now I can split this into two different fractions and distribute the limit throughout. So it's the limit as h approaches 0 of the sine of x times the cosine of h minus sine of x over h. And then that's going to be plus the limit as h approaches 0 of the sine of h times the cosine of x over h. Is there a question about that? Those of you who are live streaming, if you want to type in the questions that you might have as we're running through it. Anyway, all right. Now, at this point right here, does anything jump out at you that we could possibly do with this fraction? Yeah, well, factoring it out, right? Factor the sine of x out. So we get y prime equals to the limit as h approaches 0 of the sine of x times cosine of h minus 1 all over h. All right. Now, with this next step here, I know that h is my variable that's approaching 0. The sine of x right here has absolutely nothing to do with h. So I don't need it associated with my limit. Likewise, the cosine of x right here doesn't really associate with the limit because there is no h to approach 0, right? So I'm going to factor sine of x just out front here. So I'm going to have y prime is equal to the limit as h approaches 0. No. The sine of x times the limit as h approaches 0 of the cosine of h minus 1 over h. And then it's plus, so pull the cosine of x out. And it'd be times the limit as h approaches 0 of sine of h over h. Again, if I plug in 0 for h, I get 0 over 0 here. I get 0 over 0 here. So, but there is something else happening here. Does this look familiar to you? The limit as h approaches 0 of the sine of h over h. And it is 1. So this is plus the cosine of x times 1. Remember, we did that with the squeeze theorem earlier. Now, we're here, and we talked about this, but we didn't actually show the squeeze theorem for this. But do you remember what the limit as h approaches 0 of cosine of h minus 1 over h was? If you have to flip back in your notes, you can do that. It was the same notes we took, or the same day we took notes on the squeeze theorem. Yeah, 0. So it's the sine of x times 0. So I have the sine of x times 0 plus the cosine of x times 1. So what does that mean that y prime is equal to?
Cosine of x.
Just the cosine of x. Now, what does that mean? Well, that means if I want to know the slope anywhere on the sine curve, if I want to know the slope anywhere on the sine curve, its slope is whatever the cosine of that value is. What's the cosine of 0? Starts with a W. 1, yeah. So I've got the cosine. Well, this is the graph of sine, right? So here at 0, we have a slope of 1, yeah. This is pi over 2. What is the cosine of pi over 2? The cosine of pi over 2. What's the cosine of pi over 2? It's 0. The cosine of pi over 2 is 0. Well, what's the slope right here? 0. Think about this also. All right, I'm going to continue this out. So this would be your first quadrant from 0 to pi over 2. Here's pi. That would represent your second quadrant. 3 pi over 2. That would represent your third quadrant. And quadrant 4 would be from there to, again, the famous wrapper, 2 pi. Now, what do we notice about the slope of sine from pi over 2 down to 3 pi over 2? It's negative, right? Well, what is cosine in the second and third quadrant? Negative, yeah. Remember, these two quadrants, quadrant 2 and quadrant 3, is where cosine's negative. Slope of sine in those quadrants, negative. So, this all does tie in. Cosine of pi is -1. The slope here is -1, and so forth. So
does that also mean that the derivative of cosine of x would be sine x?
well, I don't know. But guess what your homework is? That's beautiful, Carl. We want to know what the derivative of cosine of x is.
Is that the homework?
That's the homework. We're not starting now. We got something else to do. All right, now, let's get another problem going. Let's say that I asked you, what is the derivative of f of x equals x to the, let's say, the 20th power? Now, what have we done in the past? We've taken, all right, we would say x plus h to the 20th power, right? What do we not want to do?
All of the factors.
We don't want to do that, do we? Again, I don't have a life, but I've got better things to do than that. So let's look and see if there's another way that we can come up with this. So let's just assume that we have a function in the terms of f of x equals x raised to the nth power. F of x equals x raised to the nth power. Well, let's use the limit definition of the derivative. F prime of x is equal to the limit as h approaches 0 of x plus h to the nth power minus x to the nth power all over h. Again, n just represents whatever your exponent was. All right. Now, how do we think about the expansion of this? Well, let's look real quick at Pascal's triangle. And I'm going to go one more, 1, 4, 6, 4, 1. And again, we don't want to go out. We would actually have to have 21 rows to hit x to the 20th. Because remember, this is x plus h to the 0th power, x plus h, the coefficients for x plus h squared. And we looked at the coefficients for x plus h cubed. But that's as far as we've gone with it in this class. But that's where we are. So we want to look at what this expansion would look like where we don't necessarily know what the n value is. So I'm going to start with f prime of x equals to the limit. And y'all don't write this down. Just hold up, because this is something that you can take a picture of after we finish it. Or you can watch it, because it's going to be viral on YouTube. All right, so think about what the first term is. Well, the first term is going to be, your leading coefficient is going to be 1. So it's 1 times x to the nth power. Right? This line right here would be x to the 4th times, or plus 4 times x cubed h, right? Okay. I don't know why I put parentheses there. Well, so what is my second coefficient? Well, it'd be 20 if I was doing x to the 20th, right? But what is it in this case for this random problem? Just n, right? Yeah. So we've got n times x to the n minus 1, because your second x term, you're subtracting 1 from it. And then times h. All right, what's the next term here? Well, it's going to be n times n minus 1 over 2 factorial. So think about the third term in this row right here. It would be, your n was 3, so it's 3 times, what's n minus 1? 2. So I've got 3 times 2, which is, and then divided by 2 factorial, which is also the same thing as 2, would be 3, right? Or let's try it with this one. What's 4 times 3?
12.
And what's 12 divided by 2? 6. All right, so this becomes x to the n minus 2 times h squared. All right, plus, let's go to the third term. The third term, or this would be the fourth term actually. The fourth term is n times n minus 1 times n minus 2. It would all be over 3 factorial. 3 factorial is 6. So let's think about it in terms of this row right here. N is 4, so 4 times 3 is 12 times 2 is
24.
and 24 divided by 6 is 4. You're good, you're good. All right, so now we've got x to the n minus 3 times h cubed. And we could go on and on and on and on and on here, right? And y'all probably think I am. But let's break this and again, we don't know what n is. But let's go all the way down to the next to last term. So that would be, the next to last term, we end up getting n back as our leading coefficient, but it's because it's n times n minus 1 factorial over, remember this number factorial is always one less than the term we're on, so it'd be n minus 1 factorial times x, it'd be to the first power at that point, and then be times h to the n minus 1. And then my final term would just be n factorial over n factorial times h to the nth power. And then it would be minus f of x, which is just x to the nth, all over h. So we did some pretty good expansion right there, didn't we?
Good is a strong word. Good is a strong word.
Yes, it is. Okay, well, we're going to cheat a little bit here. Because what do we know happens on the next step? We get some stuff to cancel out, right? If it doesn't have an h in it, it should cancel out. But let's also factor an h out in the same step, because that's also what we've always been able to do in this step. So what cancels out?
The first and the last one.
Yeah, x to the n and x to the n. They go and play with the dodo bird.
So, and I believe that, yeah.
So now let's factor h out of all of these terms. So I've got h times n to the times x to the n minus 1. And I factored the h out, right? All right, plus the next term would be n times n minus 1 over, I'll just write 2 because that's what 2 factorial is. And then this is x to the n minus 2, and I factored an h out of here, so I've got h to the first power, right? My next term, I'm factoring an h out, so it's going to be h squared right there, right? So n times n minus 1 times n minus 2 over 6 times x to the n minus 3 times h squared. Keep going. Now, I'm at n times n minus 1 factorial over n minus 1 factorial. And this is x times h to the n minus 1 would be h to the n minus 2. And then plus, let's just call that 1. So this would be h to the n minus 1. All over h. Everybody okay with that? This is about to get good. This is about to be worth the price of admission. All right. So now, h is going to play with the dodo bird. So we've got f prime of x equals, all right, it's the limit as h approaches 0. So let's plug in 0 everywhere we have an h. So this first term doesn't have an h, does it? So it's n times x to the n minus 1 plus. Now, what happens when we plug in 0 for h here? It's 0, right? All right. What happens when we plug in 0 here? 0. And what happens throughout? Just a bunch of, we're adding 0 a bunch. It's kind of like when I'm averaging some of your grades. So, made me laugh, and that's all that counts. All right, so my final answer here is just f prime of x equals n times x to the n minus 1. So, if I ask what is the derivative of f of x equals 20, f of x equals x to the 20th power, what is n? 20. So it would be 20 times x to the 20 minus 1, which would be 20x to the 19th power. So guess what we don't have to do from now on when we're dealing with our exponents? We don't have to do Pascal's triangle. We don't have to do the limit as h approaches 0 of f of x plus h minus. We just know if I'm given f of x equals x to the 15th power, my answer for my derivative is 15x to the 14th power. Hold up. All right. Okay, good. Now,
You know, I'm thinking.
Composite.